And that is easily my most controversial belief about anything that I've ever shared in the classroom. Please keep it only between us. Welcome back, algebraists. So today we are jumping in to 1.2. And in 1.2 we have one main focus and like one main objective. We are going to talk about graphing. Now, there's a lot that goes into graphing. I might teach it very differently than you've done it before. That's okay. I want to hear how you do it if it's different than mine. But when we look at graphs, what we're really going to be focusing on in this section is transformations of graphs. So, transformations. Okay. When we see a transformation, there's only a few different types. We are talking about what are known as rigid transformations for the most part. So how can I move a graph and change its general, like some of its characteristics without changing what it is? So if I have a parabola that opens, and you don't have to sketch this, just me talking. That's a parabola, right? Could I take this whole parabola and move every point this way, some amount, so it becomes the same size and shape, but now it looks like this? Could I move it up and down? Could I do this to it? Maybe move it and flip it?
Yes.
Okay. Could I make it super steep instead? Is it still a parabola? Yes. So now we're changing the shape, but it's still a parabola. Can I make it real wide instead? So all of those are still just parabolas, right? Okay. Our goal is if we know what the very most basic version of a function looks like, we can be given the ugliest, worst looking function ever and have a pretty good idea of what it's going to look like, just if we know how these transformations happen. So for our lesson today, our very first kind of thing is we're going to learn how to use these calculators a little bit. So I have a question for you guys. I want you, this is just kind of our motivation, it's what we call the explorer. So before we even have a section, we are going to graph a few things in our calculator. I want us to graph, using our calculators, a lovely function. We'll call it y equals x squared. All right. Now, just for the record, x squared represents a parabola. Can you give me a simpler expression with an x squared in it than that?
No.
I don't think so. Like that's 1x squared plus nothing else. That is the very most basic. This is called a parent function. There's a parent function for the quadratics. It's that. There's a parent function for cubics. It's just x cubed. There's a parent function for every type of function that you've ever dealt with. This is a quadratic. So what I want to know is from this, what changes to our parent, and I'm just going to say what changes because we already have this written, with, and we're going to name a new function that is just some change of this. So let's say h of x equals, and instead of just an x squared, and I'm going to name one more time, I'm going to write equals f of x up here. So whether I call it y or f of x, we're talking about the same thing. Just to be clear, y or f of x, okay? So if I were to take f of x minus some number c, I want to see what happens. And I want to be able to make sense of what this actually means. So before we even touch the calculators, if I have this function, and in pink it's just us talking, whenever I change color and write it off to the side, it's just to use to talk about, okay? If we have f of x equals x squared, could you guys find me f of 3, you think? So I'm good with that answer, but I need to know what's the how part. What do we do to figure out f of 3? So anywhere that there's an x, which there was one right here, right? And I just replaced it with a 3. Which means anywhere in my expression, my function, my equation, that there's an x, what am I going to replace it with? 3. This is how we evaluate those functions. And I assume you've seen this before. It might be rusty. But if we had a bigger, uglier example, anywhere that there's an x, we would just put in more 3s. Everybody cool with this? Okay. So if I see f of x minus c, this literally means anywhere that there's an x, we're going to replace it with a what? So if we're 3, for sure, what if it's this? If I do f of 3, every x gets replaced with 3. If I do f of x minus c, every x then gets replaced with a what, you think? If I say it's just x minus c instead, like 3 replaced it here, x minus c will replace it here. If that doesn't click yet, it will. So we're going to dig into this. On your calculators, if I want to know how to graph a function, what do I do first? Or, so I don't go right to graph, although I can see why that's reasonable. Y equals J. Where did you find the Y? I'm talking loud because of the microphone. Where did you find Y equals J?
On the top left.
Very top left. Now, these calculators, I think most of you have probably used them. If I didn't say this yesterday, just to see like very basics of these guys. If I want something on this calculator, all these buttons just are normal, right? So I see two things. I have a minus sign. What's this one?
Negative.
What's the difference?
One subtracts, one is a negative.
Good. Yeah, like it's exactly that. One is literally minus. The other one is, you can't switch them. Okay, that's the weird thing I don't really love about these calculators. What if I wanted to, I don't know, get the button mem right here above plus in blue? How do I access that? Second. There is a second button up here. So if I wanted to get into my memory, I would hit second. It will highlight, it'll show an up arrow on the cursor, and I know I'm in the second menu. Same with alpha. Anything written in green is here. Here's the deal. Calculators are really useful. They save us a lot of time, and it takes a lot of the tediousness out of math. If I ever pick up a calculator out of there and I see a bad message written with letters because you guys have the ability to do so, you will do all of Algebra 2 with no calculators. Cool. So no profanity, no racial slurs or anything like that. Don't be dumb. Okay. Cool. Have you used one of these calculators before? Okay. You have your own? Is it an 84? Okay. Do you have it now? Okay. If not, it's not a huge deal. If you have your own, you're welcome to use it. But if it's anything other than a Texas Instruments, I probably won't know how. Okay. So we'll come back to that, Marielle. Do you have a nickname?
Yell.
Yell? Okay. Like Yell? Okay. Cool. All right. So check it out. In y equals, we can graph this. So, whoa, I hit second. So I just hit that again. Now in here, there's a few things that are really irritating about these calculators. When you guys go in, are there some numbers in there? Like some of them have functions. Just hit the clear button right here. It'll get rid of it. Okay.
Okay.
You sure?
Yeah, mine didn't look the same for a sec, but it looks.
Okay. So if I want to type in x squared, which is going to be our very first one. Did you see how we got to this menu? Okay. Y equals in the very top corner. Really important when doing calculator stuff. If I do a step that you miss, stop me, interrupt me, like really interrupt me legitimately. Because if we get 5 steps ahead and you say, Mr. Holloway, how did you do this thing 10 minutes ago? It's going to drive me crazy and I will never shut up about it. Yep, so if there's already stuff here, hypothetically, let's say it was here, I'm just going to use this direction pad, the D-pad. I'll go here and I'll hit this clear button. We'll get rid of it. Okay, so I want to type in x squared, but I don't know how. Who does? Hit it. What do I do?
Press the x squared button.
X, like this one?
Yeah.
Okay, ooh. It gave me the square. That's good, like we're close. Not quite.
Oh, that's square root.
Second x and then squared.
So we actually don't even need the second. Notice this button right here. We have x, t, theta, and n. If I type this button, x. Okay, now this square is just for squares. You can get a square or an exponent, the square specifically by hitting this button, x squared, if we had a bigger exponent that we needed. There is a caret button right here. So if I wanted x to the 5th power, I would hit this caret. It's just an up arrow. It'll take me up to the exponent and I would hit 5. Really important if you use the caret button. If I wanted to write x to the power of 5 and then plus 1 afterward, everybody always makes this mistake. Am I correct?
What do you mean?
So I want this on my calculator. Is that what I typed?
No.
Why? Why did it do it wrong? If you use the caret button, it sticks you into the exponent, and you have to tab to the right until you're out of it. Anyway, we have x squared. We all cool? Do you all have x squared on your screen? I have x to the 5th, so I should probably fix that. Okay, I'll change mine to squared. I will hit enter, so it saves it. And now if I want to see the graph, what do I do? Now we'll do the graph button. Check it out. It'll do it. Here's the graph of y equals x squared. Right now, we reset all the calculators this morning. It is set to the window that we see is negative 10 to 10, negative 10 to 10. It's just a regular one. Okay, so on our warm-up, I said x minus c, and that's really general. We're going to make it more concrete. For now, we'll try, for this one, What if I wanted h of x instead of x minus c, which is kind of ugly? I want it to be, I don't know, x minus 2 squared. This is going to take that graph and it's going to move it somewhere. Now, in this case, what was the c that I chose? It was 2. Cool. So here's what I would like you to do. Back to our calculator. I want to keep x squared up. Now, don't graph it until I give you the go-ahead, but we're just going to go to y2, and we're going to type in x minus 2 in parentheses, because it has to go in our parentheses. So we'll have parentheses x minus 2. I'll close the parentheses. Don't graph it yet, but I'll make it squared. Do not go to your graph once you have it entered.
How'd you go back to the...
So back to y equals.
Oh.
And then one of the things that with these expressions, they're not huge, but you guys ever remember, like, if I did something like this and I just didn't want, I wanted to change a single number, or I need to change multiple things, you have to edit everything, right? Mm-hmm. You don't. We'll find a way to make a mistake and then figure out how to do it without having to retype everything. Okay.
Where's the parentheses button?
The parentheses are above 8 and 9. Left parenthesis above 8, right parenthesis above 9, and we have x minus 2 squared. Okay, before I hit graph, this is going to change where my graph lives on the coordinate plane. How? It can move to the right, to the left, up or down. Jade thinks to the right. Why?
I remember when you're subtracting, it goes to the
Okay,
right,
good.
adding goes to the
So let's check. I think I agree with you, but I want to confirm that. When I graph this again, as long as I've hit enter, it shows me x squared still, and then it draws the second graph. Jade thought that when we did x minus 2, it was going to move it 2 to the right. Was he correct?
Yeah.
Looks that way, right? If here was the very bottom of my graph, go 1, 2 over, it looks like I'm there again. It did move it 2 to the right. Did you get this on your screen? Okay. What if I wanted a function that moved it 3 to the left instead? How could you change this to move me 3 to the left? Maybe. Try it. If minus 2 moved it 2 to the right, try something to see if we can get it to move 3 to the left. Jade said plus 3.
Oh, to the right again?
I want 3 to the left.
Oh, yeah.
You think this is 3 to the left?
Plus 1.
So maybe try it. Let's see what we get. I tried what Jade did on this one. So there, I see where the issue is. All right, now I'm picking it up. You're going from the previous graph, right?
No. Y equals 2? Or y 2?
Yep, so I want to keep the regular, the parent. I'm going to keep this one up here. And if I graph this, how do you think it moved the graph?
4.
So from here, what do you think it did?
5.
Let's check. Because I'm not sure what your 5 means, but let's see if we agree with it.
5 moves.
Here's my original. Did it give me the exact same graph, just moved to the left?
Yes.
Interesting.
But it moved to the left 5.
So from the original, yes, but we're going to clear this up because that's the 5 thing. You're thinking from the original minus 2, right? 5 to the left of that is where this wound up.
Yes.
Yep. How about just from the x squared? This moved how many to the left? 1. And the scale is kind of hard to see here because of the dots. I think it's 3 to the left. I'm only ever going to reference from the parent function. Did I lose? Are you good on B?
Yeah, I'm just a little bit confused.
Okay, we're gonna summarize this. Don't worry. Okay, what if I wanted to do this? I want you guys to tell me what happens if we have f of x equals x squared as our parent, but I want to know what happens when we graph h of x, and maybe it's something that looks like 3 times f of x. Which, do we have f of x written somewhere on here? Like, do we know what it is? What do we say f of x was equal to? Anywhere up here.
Y equals x squared.
Okay, so if I did 3f of x, do you agree it's just 3x squared?
Yeah.
Okay, how is this going to change the parent function, f, just x squared? What's it going to change about it? What are your gut feeling? It could be wider, it could be the exact same, it could be thinner, be upside down.
Wider.
Wider? So let's see. Change y2 now. Let's do, instead of x plus 3 squared, let's just do 3x squared. So 3x squared. I heard wider. Anybody think it's going to flip it? Okay. I'm not going to hit enter on mine. I want you to hit enter on yours to make sure we can see it. So 3x squared could be wider, could be thinner, could be the same.
Oh, I
If you think you see a trend, go one more, add y3, and try to make it more changed. So a bigger number than 3 might do that. You graph 3x squared? How did it change the graph?
Yes.
What did it change about it?
Go
Okay. So just to compare, here it is, right? There's the original and there's the second one. Did it get thinner or wider? It got thinner. Okay. Now, what actually happened can be challenging to pick out, and we'll see why. But there's a lot of things that can change, right? Okay. I'm going to scare you guys, but then we're going to, like, unscare it. Because it's going to look terrible, but I promise it's not. We're going to make all of this super clear is our goal. We got a lot of time. So in here, we see that this, just for our sake, so this one we saw that it went x minus 2 was right 2 units. That's what this one did. And when we did this, it did what to it? How did it change the graph? Thinner. What if we wanted to make it wider? Maybe. Okay. Those two, we're just learning to play around with the calculator. That was all that was for. We're going to generalize now. So here we go. We're going to jump in today, and we're going to talk specifically about transformations. And because I'm lazy, I'm simply going to call these transforms. We're going to take out the Asian part of this. Okay. To transform a function, all we have to do is move left, right. We'll do some up and down, and that has a specific name. If we just pick up a figure and we just move it without changing the way it's oriented, so no rotation or anything, do you remember from geometry what that's called? Translations. There's one thing that we can do. We can translate left, right, up, or down, and we'll learn how that works. What else can we do? Can you take a parabola that's happy and opening upward and flip it?
Yes.
It's like it, gosh, it's almost like a mirror. What do mirrors do?
Reflection.
Reflect, or reflection. So translations are a type, reflections are a type. This other one is going to be challenge, and I'm going to use one word instead of two for now, dilations. Have you guys, and this is a weird question I know, have you ever stood in front of the mirror in a dark bathroom and then turned the lights on and looked at your eyes really carefully, closely?
No.
Do
Oh,
it.
Yeah,
Do
is.
it. Do it. Your pupils, like you can see them changing, and it's wild to think about. If you've never done it, you should. Okay, dilation is what your eyes do when they get bigger or smaller. It's called dilating. That's where this comes to my mind. So this is changing steepness, how thin, how thick. Now, here's the scary part of it. We're going to get a really mathy statement, and then we're going to pick it apart. Given a function, and I'm going to say the graph, or a graph if you already have that written. Given a graph, y equals f of x. So it's just some function that tells us how to graph this. We get transforms by changing, and I'm going to let you guys catch up, and I'm going to leave a little blank space, and I'm going to put a main, like a star here, because there's a really important, scary looking function that just looks scary. It won't be bad. Cool. Given some graph, we get transforms or transformations by changing stuff. Now, the things that we're going to change, just so I didn't miss any of them, we're going to consider functions that look like h of x, which is just some change. So when we introduce the shift 2, we called it h instead. Okay, we're going to say that these things will take the form, and y'all ready for the scariest thing you've seen in math probably? A times f of, more than that, b times x minus h plus k. It looks pretty gross, I assume. It's not bad. It kind of looks that way, but I promise it's not bad. What we care about is what does changing A, B, H, and K do to our graph? So the cool thing is that we'll redefine this, but I think we already saw what happens when we add a minus something. If I had a minus 2, what did it do to my graph?
Add. No, sorry.
No, you're good. I think you probably have it. What did it do when we did a minus 2? I don't know where it is.
Here. It went right to.
So whatever this H is, that's probably going to tell us how far left or right we go, depending on its sign. The A that was out in front of it, what did it do when we picked 3? It made my graph thinner, is how I would word that, or steeper, if you'd rather word it like that. Now, how we interpret these in each case, it varies depending on how hardcore we want to get, but we're going to dig into all of these. So I'm doing this very different than I did first hour, just so you guys know. If I'm going too fast, what do?
Interrupt.
Yes, please. I'm also, just want you guys to be very clear, I'm a nerd. Like, I could teach all of this without ever looking at anything, but I like my pretty notes that I still think are nicer than the book. So I'm writing a math book right now. Cool. All right, let's dig in. As we look at these, right off the bat, when we graph, and you will have to do some by hand here in a little while, we're going to deal with some of these transforms. Let's go ahead and knock them out. Of these, what do you think is the easiest? Left, right, up, and down. That's like one motion. That's called a translation. Reflecting, or changing the shape. What do you think is the easiest of those?
Changing the shape.
Really?
Yeah.
Interesting. I don't know that I agree with you, but that's totally subjective. Like, there's no right or wrong. What did you think?
Wait, translation is moving it this way?
Yep, left, right, up, or down.
I think that'd be the easiest.
I think me too, personally, just because we don't have to change anything else about it other than its physical location. Let's start there. So in my notes, I do stuff very outliney. So if we're looking at transforms, our first transformation that we're going to look at is these translations. Now, up, down, left, or right. We're just sliding our graph. For our translations, they're super easy to deal with. From our function here, it is this h value that we see that is going to impact our translation. So the way that I remember that, and your book uses a different letter, so if you're looking at their books, be careful. Doesn't really matter what letters we use, it matters where they are in this expression. I use this silly device. H is horizontal. Notice the alliteration. H is for horizontal. This value right here is all that it changes. So as we're looking at that, when we see something f of bx minus h, like that's kind of intimidating. Let's consider the following function. So we'll do a quick example just to see if we can make it work. Let's say that h of x is, I don't know, we'll use our quadratic since that's what we're stuck with. X minus 3 squared. For this, what direction did it move? To the right. Now, it's weird because in my mind, I want to think minus is to the left. But notice, in our expression, we already have h just written here, right? What is h in this situation?
3.
3. It turns into minus 3 because the form that we write it in. It's already minus. So here's our rule. If h, which I'm going to draw an arrow to it because this is h, can I change this to a different letter that we don't have to erase stuff? What could I change it to?
What do you mean don't have to erase?
Instead of h of x, because I don't want to confuse h and h. Is there a letter that we can make this look like?
N. Oh yeah, W.
W, I like it. Good call. Okay, if h is greater than 0, which it was because we picked 3 to plug into the x minus h, we move right. There's one possibility. What's the other possibility for h though? If h is less than 0, what's it going to do? I think you said it, but I didn't hear. I heard move left. Now, when we're looking at these, that is it. And we'll make sure, like, we're going to set all these things out. There will probably be a little bit of confusion. I don't want you to sit there going, oh, gosh, Holloway didn't really talk about it. I'm going to list all of them, and then we're going to do a bunch of practice with it. Cool. All right. So this takes care of left and right every single time. What's the other direction you can move, though, if we're just translating? up and down. So this is stupid, and I'm well aware of that, but check it out. I use K is for vertical. And I know this isn't how you spell it, but it's a dumb thing that I use to help me remember it. So I want you guys, just using your calculators, let's see if we can figure it out. If we had the graph of x squared, and it's still stored on your calculator as y1, if you make it be x squared plus 2, it's going to change your graph somehow, same as x squared minus 3 or 4, any number will. I want you to tell me how it happens. If k is positive, what happens? And if k is negative, what happens? And I want you to check and verify on your calculator. One more time. So for your calculator, you still have y1 as x squared, right? For y2, I want you to change this plus k number. When you write just x squared, there really is a plus 0 out here. We don't write it, because why would we write it? But it's there. I want you to see what happens if you pick a positive k, so it's like plus 5, or what happens if you pick a negative k. I want to see what it changes on your graph, and I want you to be able to tell me. So check on your calculators. And I'm going to come be really nosy just because I want to see. You must have did plus 1. So on this, all we're doing is I just want to mess with that k value that's on the outside. So I'm going to delete the 3. And then let's just, outside of this, let's add a k. So pick your favorite number. Sure. When we write this, how's this going to change my graph, do you think?
I have mine.
Oh, so let's keep one of them normal. So we'll just keep this as the parent function. And we'll just get rid of this, so it's just x squared. And then all I want to know is, all I'm changing in this one is k. I want to see what happens. So let's graph it. Here's x squared. And when we wrote plus 9, what did it change about it? Okay, what if we do minus? So I would keep this one. Let's go to this one, the second one, and just change y2. X squared plus or minus your favorite number. Before you hit graph, what do you think it's going to do?
It's gonna make it.
So shot in the dark, even just if it's gut feeling, it's hitting it too, sorry.
It's gonna move to the right.
So let's check. So there's x squared. Oh. How did it move?
Oh, it's because it's on the y, right? So
Yep.
it's gonna go down.
That moved down, right? Let me see your graphs. You must have done plus 4 or 5. So when you did plus 5, what did you do to your graph?
Make it go up.
Up. So check it out. If k is positive, based on whatever number you picked, it went up whatever that number was, right? Up k units. What if it were negative?
Go bigger. Go down.
Try it. Did you use the negative number as well? Okay, so I'm just going to change the words that we used, but I think we're on the same page. If you did minus some number, did it go down some number of stuff? Awesome. Now, what we've seen, and there's a lot of examples of this, and it's weird to get used to the format that we use with F and H and all these changes, but we're going to build it up. H is for what? Horizontal. K is for vertical. Okay, so we have H and K kind of knocked out at this point. Now there is a bigger connection that I want you to see. We're not going to dig into it crazy yet, but if I were to take a parabola, and this is a challenge for you guys, I want you to try to come up with this. You don't have to write it down, just on your calculator, okay? Graph h of x, which moves f of x equals x squared. That's our regular old function. I want you to move this thing left 3 and down 1. I want you to write the equation, and you can do it on your calculator, play around with it, but I want you to take x squared, that regular y1 that we have, and using just h and k, see if we can get it to move left 3 units and down 1 unit. We can do this one together if need be, but I'd like you to try something on your calculator. Try one thing, and right or wrong, we'll deal with it. Or, I'm going to pause it, and we can talk individually stuff. So check this out. If we get f of x, this is a regular function, right? This is x squared, that's our parent. We're going to do this in 2 steps, and we'll combine it into one big one. What if I want to move this left 3 units? What goes in for this h value right here?
W.
Plus 3.
Oh, yeah.
Plus 3. So check this out. That means that if I'm looking at where that h is, notice it's inside the parentheses. I'm going to refer to this as the argument all year long. F is the function. The argument is what f of what's inside of the parentheses. So check this out. If I were to find f of x plus 3, that literally means that anywhere there's an x, what do I replace it with? So I think I erased it, but we're going to hit it. At the beginning of the class, when I asked you to evaluate f of 2 or 3, whatever the number was, anywhere that there was an x, we replaced it with that number, right? What did I put inside these parentheses instead of just x? It's f of, what's this? The argument.
X plus 3.
Good, that's my argument. Instead of just x, I replaced it with x plus 3, which means anywhere there's an x in my actual function, I'm going to replace it with, what was that argument again?
X plus 3.
Good. If I graph just this, does it move me left 3? That's how it works. This is that x plus h part that we're talking about. That's so weird to get the notation to set with. Okay, we've done this part. What if I now want to move it down 1? Where's that k with regard to everything else in this general form? Is it inside the parentheses or outside the parentheses? It's outside. So if I wanted to do f of x plus 3, this part already moves it 3 left, right? Now outside, how do I move it down 1? And I do it outside of it, which means this looks like x plus 3 still, squared, and minus 1. When I see this graph, and I want you to verify for me, check in your calculators, did it really move me left 3 and down 1? I think so. Verify for me, though. I trust Jade. I trust you, Jade. Check it. Or, if you guys, are you guys comfortable using your calculators?
Yeah, using.
Yeah.
Kind of. Like, can you type this in?
Yes.
Like, in the interest of saving time, and honestly, what I would suggest is, if you guys have cell phones, obviously you do, Desmos. I would strongly, they have an app for it, but I can look at this all the same. If we do f of x equals x squared, let's see, I'm going to make this f of, what did we just say it was, x plus 3? It moved me 3 to the left, and then down 1. It did exactly that. More so, if we did f of, well, we'll try another one. Okay, one more. Let's check it out. On, I'll call this A. On B, we're going to take x squared. It's the same parent function. And we're going to be a little bit more vague this time. A little bit more mathy, but you're going to ask and we're going to clarify. I want you to find h of x moves f of x, let's say left 1 and up 2. What is f of x still defined for as this example? Did we change what f of x was? Are we still working with x squared? Still working with x squared. I want you to find me the changes to f of x, like we did on the previous, that move it left 1 and up 2. Inside of my parentheses, what do I need to add to get it to go left 1?
You have to add, not subtract.
If we want it to move left, yes. And I know it's super weird. What should I put here if I wanted to move left 1?
Plus
1. What if I wanted to move up 2?
plus 2.
So, Beatrice, I 100% understand why you would want it to be minus, because this one's opposite. The outside is not. And because it's that x minus h format, if h is positive, you get x minus some number. So let's check. If we do x plus 1 squared plus 2, does it do exactly what we want it to? X plus 1 squared plus 2, left 1 and up 2. I think so, right? Okay, here's a bigger takeaway that I want you to notice. We are not going to have homework tonight. We're going to keep rocking tomorrow. We'll summarize. Tomorrow's going to be a bunch of examples. It might be easier without the calculator in reality, but I want you to notice something. The last function was x plus 1 squared plus 2, right? What was h in this problem? What's this number? It's not just 1, though. If it's normally x minus h, what do I have to plug in for h to make it turn into a plus 1? -1, because the x minus thing. What is k in this problem? The vertical change. 2. Okay, last little thing that I just want to linger in your brains. -1, 2, right? For x squared, my parent function, the vertex is right at 0, 0. Right? I can see it. For the function that I've moved left 1 and up 2, where's its vertex? Hey, maybe graphing quadratics can be like a million times easier than you think it will be. Tomorrow, be prepared for practice. Cool. Appreciate you guys. Later.